In this video, we're going to look at using a linear equation in two variables to be able to model a real-world situation. Just like anything in math, linear equations in two variables don't help us a lot if we're not able to apply them. So modeling is a way that we can apply a linear equation in two variables to a real-life situation. We're going to work with it the same way that we always have. The only difference is we're actually using it as a model to represent some kind of relationship in a real-world situation. So let's look at an example. The average cost of producing a bicycle can be modeled by the formula below, where C represents the total cost of producing N number of bicycles. If the company has $15,000 to spend on bike production, how many bikes can the company produce? So we see that we have our linear equation in two variables. We've been working with X and Y as our variables. In this case, we're using C and N, but I want you to notice that regardless of what variables we're using, we're still going to use the same process. So we were told that the company has $15,000 to spend on the bike production, and we want to know how many bikes can the company produce. So we were given one of the values and we're asked to solve for the other one. So what we have to decide is the 15,000 representative of C or N? Well, remember that C is the total cost of producing and N is the number of bicycles. So since $15,000 would be representing a total cost that we have, or the company has, to spend on the bicycles, 15,000 is going to replace C, and what we're looking for is how many bicycles can the company produce, and so we're going to be solving for N. So just like in our previous examples, we plug 15,000 in for C, and we solve for N. So we subtract 1,200 from both sides. So we get 13,800 is equal to 50N. Divide both sides by 50. And we get that 276 is equal to N. So this tells us that with $15,000, a company could produce 276 bicycles.